Let's finish constructing the learning curves for our model. So we'll just use a simple max depth, or not very deep tree, so just 3 depths, just for illustrative purposes. Let's go ahead and construct our for loop. So we're going to do a for loop for n in range of 50 all the way to the size of our training set, or how many observations we have in our full training set. We're going to go by chunks of 50. So what's going to happen here is that for each pass of the for loop, we're going to increase the size of our training data we're going to use to train the model. So that's what these batch variables refer to. So the first pass we just have 50, the second pass we have 100, 150, so forth until we're using our entire training set. All right, let's go ahead and fit our model. So I'll do there, x batch, y batch. Then we'll go ahead and calculate the r squared. But since I want to plot an error metric instead of something that tells you how well the model performed, directly tells you how well the model performed, I'm going to go ahead and calculate 1 minus the r squared, such that a number close to 0 is good, a number larger than that is bad. So I'm going to append this to my list, since this is on the test set, append it to the appropriate list. Same with its performance on the batch set. So through each pass, we are calculating how it performed on the test set and how it performed on the current batch, the current subset of our training data. So we can plot those after the fact. Let's go ahead and run this. Hopefully it runs. All right, might take a while. And when you're doing this for other applications, you might want to adjust the size of the chunks. If it's taking too long, increase the size of the chunks. Of course, if you increase the chunk size, your graph's not going to look too pretty. But you go ahead and have to sort of find what's a good median, what's a good chunk size to use. Just play around with it. Let's plot our error for the test and the train, and let's see how it looks like. Okay. Here's our observation. So the blue should be our training. In fact, let's just add a legend so we can test error, and then the other one should be training. Okay, there it is. So as we discussed before, as you increase our training size, the test error is going to drop. Notice there's a big drop very quickly. Looks like within less than 50 observations, it's already kind of flattened out. It has flattened out. And looking at the training data, we see that it hasn't converged in this measure of the deviation as a measure of the variance. So it looks like here that adding more data isn't going to really help us out. So there's no need to go collect more data. We've sort of saturated our model. We'd have to use a different model. In fact, I go back here, I can use a different model, or I can go ahead and increase the depth of the tree. Let's see how that affects the training curves. Probably get something similar as well. But it looks like we shouldn't spend our time collecting more data. Yeah, very similar behavior that we observe.